Very good evening to all student members and my dear respected faculty members. So, in the present semester, now we are going to have our first technical session through virtual platform. The seminar topic for today's presentation, Industrial Automation in Assembly Line. This is just a small topic that has been covered in a subject called Computer Integrated Manufacturing System. So this is the content beyond the syllabus. So this topic is not given in the so-called subject, Computer Integrated Manufacturing System. So on my own personal interest, I'm going to handle this session. That is the content beyond the syllabus. So what do you mean by industrial automation in assembly line? What are the various, the prehistorical, the concepts that are applied for the development of industrial automation? And meanwhile, we will have a case study of industrial automation using RoboDK solver package, the simulation type exercise. And finally, we will have the concluding session of today's seminar presentation. So in this way, we are going to schedule our each and every sequential plan as listed here for your kind reference. So now, before moving to the technical session of today's meeting, let us start with the purpose of industrial automation. So why we want to have this topic as a major importance with respect to latest technological development in the recent times. Generally, assembly lines are typically considered to be more complicated and highly challenging in nature. So the main aim of assembly line is to maximize the production. So by keeping that in mind, we need to have some kind of advanced computer control system in order to automatically control the assembly line by maximizing the productivity such that we can able to perform the missions to work on itself without the intervention of human in a more accurate manner. The next objective of industrial automation, generally machines no need any break or fatigue in between as like human being. And also they don't sleep. So therefore, running the production process 24/7 becomes one of the most viable option in recent past time. Followed by the objective of the topic, now let us deeply go into the introduction to automation. So what does the automation exactly means? So let us go back to the prehistorical development of industrial automation. The very first industrial automated equipments present in the assembly line is automated belt type conveyor system. The main function of conveyor is to move the mechanical physical parts with the help of the belt pulley mechanism in order to feed forward each and every parts into the corresponding assembly workstations. So that reduces the manual labor cost by automatically feeding the parts to every assembly mission stations. So the industry automation is nothing but it will have the following subsystems like sensors, actuators, computer processors, and networking system to communicate the data between each and every missions, and also to perform the logical task without violating the sequential or precedence constraint with the goal of automating the individual production operation by safeguarding the demand rate without compromising in the deadline of completion of job. further continuation in the next slide as presented here for your reference. So in recent development, industrial automation has coupled with various wide range of modern technologies like AI, machine learning, industrial Internet of Things. These are some of the modern technological systems that embraces the conventional industrial automation by focusing the best way to speed up the productivity much more better than compared to the very conventional or oldest technology. So now let us move to the core theme of the topic which has been planned for today, automation in assembly line. So what do you mean by that? See, generally speaking, assembly line automation is one of the most critical challenging technology that has brought many new modernization changes by equipping computer assisted manufacturing process by systematically streamlining every production process as per the plan by improving the assembly performance efficiency. So the computer automated assembly line has become most mandatory and essential thing that supports the manufacturer to meet the high quality products by maximizing the demand of the cost effective option as a primary concern. So how does generally the assembly line automation functions? What are the systematic procedural guidelines to be adapted in the factory? The first one, automated assembly line generally comprises of series of assembly workstations coupled with a conveyor or a pallet. First of all, the raw materials or any mechanical components that are to be processed will be fed into the assembly production line at one end, and it will come out as a finished product at the other end of the assembly line. So this is the functional thing to be noted in the assembly line. Each workstation is designed to carry a specific set of tasks as per the capacity. And what are the various tasks carried out in assembly line? Say product assembly, product inspection and testing, then product packaging, etc. So each and every task has to be assigned with a common cycle time. All the operation has to be carried out within the availability of cycle time constraints. And the computer control system is one of the central brain of automated assembly line system, which takes care of the various logical sequence of physical operations, and thus it monitors the production process successively. And in addition to that, collaborative robots we call as cobots, that is also one of the main important assets, will be working along with the manual labor in the assembly line. So to perform such task, dangerous and hazardous task, so we require a high degree of precision and accuracy with the help of machine vision technology. So by monitoring the number of source of defects present in the process of assembly line, whether the product meets the quality standards or not. So we require a computer vision technology to monitor the automated assembly line production system. So these are the basic logical procedures to be strictly followed by each and every production company by following their own business quality standards. So what are the general use of assembly line automation? So assembly line automation has wide application in different fields like automotive, medical devices, and consumer electronics. So here, as far as concerned in automotive manufacturing industry, the main primary source of products, end products that will came out of the assembly station are nothing but cars and trucks. So through computer automation, we can able to produce such commercial products by reducing the unnecessary production wastage or production cost by maximizing the production yield or efficiency to the highest level. Now, to understand this concept, let us have a practical case study using Robotic Solver package by doing a small exercise, say simulation of robot welding assembly line with a video demo. Now I'm sharing the screen of Robotic Solver package workbench for your kind reference. So here I'm going to create a 3D model of a welding workbench of industrial automation with the pick and place robotic arm type assembly. Choose file option, select open menu, go to library samples. So here are some of the solved worked out exercise, simulated exercise for your kind reference. So out of this example, I'm just going to take the automation of a robotic welding station. So this is the simple workbench of welding station. So I'm going to do an exercise called collision free motion path planner. So what is the main objective of this exercise is to check whether the arm of the robot manipulator, how successfully it can able to reach within a given work volume or the space that has been allotted to do the different assembly task or an activity. By doing that collision mapping planner, so we can able to design the work cell in such a way that the robot arm will not collide with any neighbor obstacles such that it will able to control within the reachable unit. So let us see the collision mapping planner exercise by choosing utilities menu, click collision free motion planner, create collision free map by clicking that option. And here are some of the input metrics. So how many number of iterations? Say 5. The number of degrees of freedom. So update map. So by clicking that update map option, say I can able to measure the path adjustment of the robot arm within the given constrained work volume, so that I can effectively position the robot arm to any required the coordinate axis within the given allotted the space. Say for example, I'm increasing the number of iterations, say 15, they update the map, the collision map. So likewise, we can able to change the variables and we can able to study the path motion of the robot arm by analyzing the kinematic motion of robot arm. We can able to design the work cell or workspace. So in order to safely carry out each and every assembly operation without hitting the nearby obstacles. So this is one of the just simple exercise carried out in simulation of a robot arm. Now we will resume to the remaining presentation. Followed by the next slide of information. So what are the benefits of automation? So from this basic simulated exercise shown in the previous slide, So what we came to understand here, improved efficiency. Okay, so we can able to increase the speed of operation by improved efficiency, by enriching the quality control of end items, then flexibility to change the operation manual according to the compatibility of the production, and also we can able to reduce the manual labor cost. So these are the basic benefits of automation. Now precisely I will conclude the overall the theme of the presentation. First let us have the summary of today's seminar. So initially we started with what do you mean by an automation? What are the different procedures to be carried out in automated assembly line? And in between, we had some few exercise, simulation exercise using some tool called RoboDK Solver package. By considering all the basic key input, so what I mean to say that automation technology will provide a comfort to the business process so that we can able to modernize the production process by optimizing the cycle time of each and every assembly task such that we can position our business objective for a long-term success in high competitive market. This is what I just want to conclude as a final thing before closing the seminar meeting. And once again, I thank each and every one of you for attending the seminar. So thank you all.